Sebastian graduated in 2008, and he spent his time at Gunn doing many different things as possible, as well as after that. He currently works for Pre-Maculture Artisans, a design-built landscape architecture firm focusing on regenerative and land management. He invests his spare time propagating fruit trees and exploring the West on motorcycle. Please welcome Sebastian.
I think Mr. Paley brings me to these things to be the token earthy hippie, so I'm going to try and not disappoint. I'm worried about the way in which we present engineering in our community. I'm worried that what I saw and what I was told as a path in this community was go take engineering classes, get an engineering degree, go work for tech, go make some cool stuff and make a lot of money. Engineering as a way to make things, and I disagree with that. Engineering is a system. It is a method of analysis, of systems design. And it can be applied to a host of things. I want to present to you the concept that what you consider to be the subject of engineering is actually just the smallest sliver of where the method of engineering can take you. Our degraded environment represents a massive opportunity for creative problem solving and real engineering challenge. In our time where we see daily examples of Earth's ecosystems, the climate fighting back against us humans, famine, drought, blight, flood. These are environmental challenges that can be addressed and in many ways ameliorated by brilliant application of the engineering method. I challenge you to two things. One, create the technologies that will address our environmental concerns. Give the practitioners what they need. For example, I work in landscape architecture and land management. My job is to get the client's economic and personal goals for their land in line with the ecological needs of their land. Where I always start is water. To know how water is going to work on a site, I need maps. This is a 3D model of a site we're working on just west of Petaluma. With that, we can determine where surface waters are flowing. For example, on this site, we can determine where there's excess runoff, where there's sedimentation, where there's erosion. This was collected with a LiDAR imaging rig on a twin turboprop plane. It's a brilliant bit of engineering, but it's too expensive, it's too big, it's not accessible. So what I need from you guys is a cheap GPS-controlled quadcopter-mounted imaging rig. Design that solution. 2, engineer these solutions to the environmental degradation we see around us. Deforestation, pollution to our groundwater systems. These are all seemingly insurmountable challenges, but if you get into the doomsday predictions, you can tease out engineering challenges. I think one of the challenges that we see around us really frequently now is the drought. Our current water system in California is so heavily reliant upon state water projects and an ever decreasing reliability of Sierra snowpack, and it's proving to be devastating. Estimated 500,000 acres of fallow farmland just in California this year. We can address these challenges with engineering. If we're talking about drought in California, we really have to talk about agriculture. 80% of California's human-directed surface water flows. And this is the way we're doing irrigation and agriculture in California right now. Inefficient irrigated land, raising inappropriate crops from taking water from overtaxed rivers and groundwater reserves that we don't even know how much is left. This system is illogical, and it's not going to continue. We can either watch it die, or we can design a system that actually works in the long run. We can design agricultural systems that actually function ecologically. It's just a matter of applying the method of design. That 500,000 acres of degraded farmland, you can restore damaged and degraded land and bring it back into production. It is possible. This is just a small example of a portion of the restoration work that was done in the 90s in the Loess Plateau region in China, before and after. You can design ecosystems to mimic natural processes and actually produce production. So back to that project. This site has a lot of interesting areas. One of the areas I was really interested in was water. 40% of the surface water, the rainwater on this site, is moving off into creeks. It comes off as massive storm flows that cause issues with sedimentation and erosion into the creeks. What we need to do is slow that water down, get it down into the groundwater where it can slowly move into the creeks. One of the projects we're doing on this site, we're doing a pond. Bigger, because, you know, might as well go bigger, right? We're going to slow down that rainfall, we're going to put it to economic use, and we're also going to put it to ecological use, restoring the site. And then we won't have to be pumping any more of those groundwater reserves. Another project area, zoomed in here, that river-looking thing, that is a 10-foot deep eroded channel caused by runoff. Towards the right, there's an area where it's collecting into a valley between two finger ridges. We can take that excess water, using some good design and some very well-engineered equipment, and pull that out onto the dehydrated ridges, spread that water to where it's actually useful. This method is called keyline design. This is a project we are working on. It's a method of soil decompaction that actually can help move water subsurface from where it's in excess to where it's actually useful. This method is shown to increase the growth rate of grasses. As you increase the growth rate of grass, you can actually increase the organic matter content of soils by growing deeper, larger roots. This added organic matter has amazing capacity to absorb more water. Increase the organic matter content of that topsoil by 1%, and you can increase its ability to absorb rainwater by 27,000 gallons per acre. This is hydrological engineering. We can design systems that actually work. Compared to, say, a smaller example of a project that doesn't work. You guys might know this, it's right behind us. It's the creek diversion right here. This is taking water that should have percolated into the ground and putting it into a concrete-lined ditch where it's flushing it out with contaminants to the bay. We're focusing too much water into one site. If you guys remember the 1998 flood, 101, 4 foot of water, 50 houses destroyed, the waste treatment plant backing up sewage into the streets. Our system as it is engineered right now is not only causing damage to the natural habitat, it's also causing damage to human habitat. We can design a better system than this. You don't have to pave, pipe, and pollute all that water. You can let that water percolate into soils. You can consider water as a resource to be designed around, not a method, not a system that you just have to get rid of. An even smaller scale, which my mom will recognize. This is a landscape I did to qualify for a lawn removal rebate. It also happens to percolate in half of the house's roof water directly into the soil, not the storm drain. Plus the trees and mushrooms really like it. Water as a system you can manage yourself. And let's go back to that pasture project in Petaluma. Increasing the organic matter of soils by water management. That organic matter that we sequester into the soil, that's atmospheric carbon. It is brought down from the atmosphere by nature's wonder of a biological photochemical solar cell, a blade of grass. That is carbon that is locked in stable soil humus. We can address our water issues in a way that also helps us address our carbon issues. Agriculture can be a climate change mitigator instead of a climate change motivator. It's just a matter of design. And all of this is engineering. It is the method of engineering. What I want you to consider is that there are options beyond tech. That, yes, there are problems to be addressed. Phones have problems, cell phones have problems, clickers have problems, ketchup packets have problems. But there are also problems that will challenge you, engineering challenges that will inspire you for a lifetime. You can work on increasing the efficiency of our electrical grid, of our highway system, of reducing the waste in our food transportation system. Or you can work on this rock. You can work for this rock that gives us life, that gives us this very opportunity to be creative. I want you to consider that as an engineer, don't just work to make a product. Don't just make a living. Be an engineer that works to make our future. Thank you.